So thank you to everyone for joining us, and welcome back to those of you who I think have been with us throughout the afternoon. Last but not least, I am so thrilled to introduce Hollie Fisher. She is an engineering geologist. So just a little bit about me, for those of you who are new. I'm Alicia Newton and I work at the Geological Society of London. And we've joined with a number of societies across Europe to take part in an initiative to try and get more people into studying geology and the earth sciences, and in particular, girls and young women. So we're pleased to have Hollie to talk all about her journey and what she does, and allow you to ask any questions you might have about what life is like as a geologist. So we are recording, so we'll ask if you have any questions, can you please put them in the Q&A box? And then at the end, I'll read them out and we'll have hopefully a really good discussion. So I'm just going to turn that over to Hollie now. Thanks.
Hi, everybody. I'm just going to share my screen because I've put some slides together. So hopefully you can see that now. So I'm an engineering geologist with a company called Atkins, and Atkins are a leading engineering consultancy company. We're also global all over the world. So if that works. Here we are. So first of all, what's an engineering geologist? I'm not sure if you've ever heard of one before. I certainly hadn't until I went to university. But engineering geologists, there's loads of different types, but for the engineering that I do, I'm responsible for identifying the geological and geomorphological factors. So that's your physical geography factors that could affect construction projects, property and people. By construction projects, we mean pretty much anything that is being built. So buildings, roads, railways, but also the earthworks associated with those things like your cuttings and your embankments that your roads and your railways are going to be built on. But we also look at problems as well associated with the ground that may affect people and property that's already built. So things like landslides and sinkholes. These are quite topical at the moment, particularly with increased groundwater, and how we may mitigate those, how we can stop those from occurring. And lastly, we also deal with court cases. So where something has gone wrong, whether construction, whether something's been built on a landslide, whether that could have been foreseen if you had a competent engineering geologist, or whether it was completely unforeseeable, which is often quite the case. So quite often for construction projects mainly, we'll do the investigation of the ground and we'll provide numbers to our geotechnical engineers who will then do the design of foundations or earthworks. And sometimes we do that ourselves as well, normally preliminary design. So there are also other types of engineering geologists out there. So I work for a consultancy. So most of mine is interpretive. We get the data and we interpret it. We also have engineering geologists that come from a contracting background. So they're the ones that dig the holes and do all the logging of the ground and provide you with the data. And we also have other types of engineering geologists who are more of the kind of geotechnical engineering side. So they're the ones that will do all the design. So how did I get to be an engineering geologist? Well, as I said, I've never heard of it before. So I'll start right from the beginning of my kind of process into it. I really enjoyed doing physical geography at school. It was my favourite subject. So I did my GCSEs and A-levels with that as my main subject. I've put my grades on there as an example of, well, you don't have to be exceptional, you don't have to get an amazing grades to really succeed. So I was a pretty average student, Bs mostly, and I still managed to get into university. I went and did a bachelor's in physical geography and geology at Plymouth University. And this again because I had that really love for physical geography. In my second year of that undergraduate, we were introduced to engineering geology. And so I decided to do a term in my third year doing that. And once I graduated, I moved to the Netherlands, which sounds better than it is, but my family are from there. And I did an internship with a company called Royal Haskoning, who are another engineering consultancy. And I did the internship there as an engineering geologist, really loved it. So I ended up doing a master's in engineering geology at Portsmouth University. And straight out of that, I got a job with Atkins as part of their graduate scheme and have been here for 6 years now. And just this year, I've become a chartered geologist, which is a professional qualification. So some more letters at the end of our name after BSc and MSc. So since being at Atkins, I've worked on a huge variety of projects, most types of projects as well. I've really kind of switched between everything. So some of the more enjoyable projects for me was a theme park in Kent. It's popped up quite a few times in the media over the past few years. So you might have heard of it. It's not been built yet. I've also worked in Sierra Leone on a water supply project. That was last year, and that has actually just been finished being built this year. So it was great to see the finished work of that. And I work on some less kind of glamorous project treatment works and making them more efficient. So we have less problems in the water kind of pipeline, and also quite a lot of railway and highways. Most of these are in the southeast of England, but I also get to travel around, like I say, Sierra Leone and Scotland and the north of England as well. So I've put together a couple of slides on a typical day for me. So at the moment, I'm about 50% on site, 50% in the office being my hallway here. So when I'm on site, normally it's supervising ground investigations. So this is watching or supervising people drill boreholes and undertake trial pits in the ground. And I've done some boreholes up to 60, 70 meters down for some pipelines, for foundations, for basically anything that you can think of. But I also quite often get the chance to go and visit the site during construction. So those two middle pictures you can see, the one on the left is for a tunnel boring shaft, and they have to be quite wide because they have to allow the tunnel boring machine to be dropped down there so that it can then do your tunnel. And the one next to that is a sheet piling wall being installed in a reservoir that was leaking. And then in the office, it's no less exciting. So a typical kind of project for us would start with a desk study, and that's reviewing all of the freely available information for a site, looking at geological maps, looking at historical borehole logs, and creating a model of the site. What's there, how's it going to affect what we're building? And then what's the next phase? Well, typically that would be, there's not quite enough information, so let's do a ground investigation. And so we'll design that. Where would we like to put some holes? What type of holes would we like to do? If we're in rock, do we want to do some rotary holes? If we're in soil and we're building a pipeline, maybe we want to do some shallow trial pits. We're outside supervising that. That's the site work that you've just seen, making sure that the contractors are working to our requirements and what we need. And then we go back to the office and we do an interpretive report. And this is where we'll bring together all of that desk study information, this new ground investigation information, and create ground models, whether they be 3D at the top there, or cross sections, and there's a hand drawn on there, but we also do it all using software online. And then we also provide, the geotechnical parameters, is what we call them. So the numbers that are used for design, and then also do some of the preliminary design as well for, again, whatever we'll be building. So that was a really quick run through on me. So I guess we'll just go through questions.
Great. So I encourage everyone to get your questions in. We already have one, and that's, would a placement year course at uni help to get a job like yours? Does it look good on a CV when you're applying to companies?
Yes, it does. So it's hands-on experience, particularly if you're doing one as an engineer and geologist, for instance. It will look really great for your future employers because it shows that you already have an understanding of how we work in the corporate world. But not only that, if you do a placement, whether it is a placement year, whether it's like I did, an internship after I'd finished university, or even just a few weeks work experience during your summer holidays, undertaking these things are almost like a face-to-face interview. That's how you should really look at it. If you do a really good job, if you sell yourself, you may get a job at the end of it.
Great. And I think, so one from me, what is your favorite part about your job?
I really love being outside and working with our contractors, our clients, and our landowners. I'm a people person, and at the end of the day, what we're doing, the reports that we're writing, the thing that we're going to be building is for people. So I really love just working with these different engineers, different we also have like hydrologists, working with them, ecologists, contaminated land specialists. So just being out and working with people.
Great. So do you have a favorite project that you've done out of all of the ones you've listed?
So there's two, I guess. One was the water supply project in Sierra Leone. So this was in Freetown in Sierra Leone, which is a country in West Africa that has, over the past kind of 20 years, had some quite unfortunate events. There's been a civil war, there was the Ebola outbreak, and so a lot of people were moving to Freetown from the country to find work and to get money. So the water supply system that was already in Freetown, so similar to like how Thames Water provide water to London, for instance, they had this water supply system that just wasn't suitable for the amount of people that had come into Freetown. So us and some other companies have come in, and we have worked to make that water supply system more efficient and provide more water to more people. And some of the work that I was involved with was for some new water tanks, which were right on the outskirts, in kind of middle of nowhere, top of a hill, lots of landslides around, some really interesting geology that I'd never worked with, tropical soils. And yeah, you really got to work with the people as well that would be benefiting from this water source. Yeah.
So we've got two questions about uni courses. And the first is, does it matter which uni course you take, and would it limit your job opportunities? And then the second one is, what is the best course to choose at uni to become an engineering geologist?
So I think from a bachelor's point of view, kind of any ground engineering or earth science course is suitable. So I did physical geography and geology, and so I've got a bit more of an understanding of the kind of geomorphology, so that physical geography and how it relates to the geology underneath it. But we also have geologists that have more of a background in geophysics or structural geology, and we all have different parts to play within engineering geology. So I think from a bachelor's point of view, any type of earth science course is a good starting point to build up those kind of fundamentals. But then if you, depending on the type of engineering geology you want to get into, so what I do is consultancy, it's you kind of need a master's in engineering geology is a good way to go. And I did Portsmouth, but there's lots of other universities out there that do it. Leeds, there's a few in London as well.
So as an engineering geologist, are you limited to where you can work in the UK, or is it a job you can do anywhere?
It's a job we can do anywhere, actually. So Atkins, for instance, have companies all over the UK. I'm based in the southeast, so London and Epsom, but we also have offices in Cardiff, Birmingham, Glasgow, and also global companies as well. And the good thing about engineering geologists is that you understand, or you develop the fundamentals of engineering geology. How does clay behave? How does chalk behave? What does that mean for different types of construction? How should we investigate it? So that you can work anywhere and apply those fundamentals. So yeah, you can work anywhere.
Fantastic. And this question is, how similar is engineering geology to landscape architecture, and what's the main difference between them?
So landscape architecture, from what I understand from my friend who is one, they come in after we have done so after something has been built, after a road has been built, or some housing or something, they come in and basically tidy up the area and make it visually appealing. So when you're driving along your highways, for instance, if you're on a motorway and you look out and you see some lovely green hills on either side of your motorway, that's because the landscape architect has come in and designed that. They might have other roles that I don't know about. I don't want to belittle what they do in any way. So what an engineering geologist does, so they're involved at the end of the project. We're involved right at the beginning. We're the first people on a site. So a client will come to us and say, I want to build a waterworks at this location. And so we will go in there and determine what is in the ground, how that might affect what they want to build, what kind of foundations they will need to deal with the problems in that ground. Will they need piles? Will they need shallow raft foundations? And we're also involved during the construction phase as well to make sure that there's no changes that we haven't identified during that first phase. And also we're not often, but sometimes involved towards the end as well, where we do monitoring, particularly if you're in a high-risk site, so a site where there's like lots of peat or something that might cause settlement, or if you're doing a tunnel, monitoring some of the buildings above the tunnel, that kind of things.
And so I think we see a lot of infrastructure projects are proposed to help solve climate change, whether it's increasing public transport, getting higher speed trains. What role do engineering geologists have to play in making that better, or making it happen even?
So that's a tough one, particularly with the HS2 and stuff at the moment. It's controversial. So we often don't have a choice in what we're involved with. A client will come to us and say, we want to build HS2. We want to build a theme park. What we can do is make sure that what they are building is cost effective, and that our design is cost effective, is sustainable. When we're designing earthworks, for instance, maybe we want to use locally derived materials, so that you're not transporting loads of other stuff in, so that it's kind of matching up with the local ecology and ground conditions. We can make sure that we do our work on time, so that there's not so many of these extra costs associated with design and reporting. Those are probably the main things, but yeah, we don't really get a choice because we're business at the end of the day. Great. Sounds bad.
No, it's so how long do you typically spend on one project?
Depends on the size of it. I am working on a project at the moment which is the first reservoir to be built in the UK in over 30 years. And I've been working on that for a year now, and we're just coming up to the kind of planning application for that now. And that won't be completed for another 10 years, the construction, but my input will probably finish next year. So that would be 2 years. But then I've worked on what we call design and build projects. So normally for government bodies, and also like Thames Water, that kind of thing, where there needs to be a really quick turnaround, and I'll work on a project for a couple of months, from the first phases to getting ready for construction.
And we have a technical question now. Do you have any opinions on self-repairing concrete, and should we increase the use of this type of concrete?
I don't know anything about that. Sorry, that would be a structural engineer. So I
know, I was like, oh, is that a thing? Would that fix the pothole?
I can tell you about how ground can be aggressive to concrete if you'd like, but that's about it.
Hey, thanks. Yeah, I guess if there aren't any other questions, I'd have one last question, which is, what would you tell someone who's interested in becoming an engineering geologist? So say they're like 14, 15, 16, what should they start doing to get ready?
I would say contact people, contact companies, do a bit of research, find out the names of some companies, and try and get some work experience with them. Work experience is free. It's a couple of weeks in your summer holidays, and you'll get some really valuable experience on what we do as engineering geologists, some of the projects we work on, and if we're allowed back in the office, what it's like working in an office, and sometimes maybe going out on site. So contact people, use LinkedIn, just message people and say, I'm interested in it, can I come and join you? And then if you're interested in taking that further, you can have a look at apprenticeships and placements, and of course at university, when you get into looking at your dissertations and things, maybe have a more engineering geology focus to that. So mine, for instance, when I did my undergraduate on geomorphological mapping, but for a railway. So yeah, just internships, work experience, and then yeah, focus on your dissertations, I guess.
Great, well, thanks so much. And thank you to everyone who's been with us both during this session and the rest of the day. Thanks again to Hollie for coming and telling us all about being an engineering geologist and making it sound so fun and exciting. So hopefully everyone, if you are interested in learning more too, you can go to the Geological Society's website, look at our careers pathways, look at our degree information, and yeah, just keep looking into various things in geology, and we hope you find the career and home that's right for you. So thank you so much to everyone. And thanks again, Hollie.
My pleasure.
Thank you.